Good morning, or afternoon, I guess. I'm already late getting this video posted. So here we go. We are simplifying radicals. So on the assignment from yesterday that I'm also posting the video of today, we should have used the quadratic formula, and you ended up with the square root of 160 and the square root of negative 284. And you probably didn't know how to simplify that any further. So it was okay that you left it like that. But today we are going to talk about how to deal with these things and how to simplify them. So a couple things we need to think about first is the product raised to a power rule that says that the square root of a times b equals the square root of a times the square root of b. And we take this from the product raised to a power rule from Algebra 1 that said if we had something that looked like a squared times b squared, that's the same thing as saying a times b squared. And so what we need to apply here is that the square root of a is the same thing as saying a to the power of 1/2. So that's what we're doing. We're raising something to the power of 1/2 when we're taking the square root of it. Okay, so that means that we can use the product raised to a power rule and convert that to radicals. So we can say a to the power of 1/2 times b to the power of 1/2 by the product raised to a power rule states that means a times b can be raised to the power of 1/2. These two things are equivalent. And what that's saying is the square root of a times the square root of b equals the square root of a times b. That's exactly what that means, okay? So we just need to remember that if we're multiplying two things underneath the square root, we can separate them into their own square roots and multiply them again. So I'm just going to erase this off. And the second thing we need to know is that the square root of -1 is I. So this is the imaginary number I, and it is the square root of -1. So just like the square root of 4 is 2, the square root of -1 is I. Okay, so this is a new rule we have in Algebra 1. All right, so we're going to simplify some things. We have number 1 here is the square root of -32. Well, I'm going to simplify this first by rewriting it as the square root of -1 times 32, which means I can rewrite this as the square root of -1 times the square root of 32. And we said right here that the square root of -1 is I times the square root of 32. Okay? So now I want to simplify 32. I think I can break that down just a little bit more. You might remember doing this in Algebra 1, so we're kind of just bringing this back into the front of your mind. So what I want to think about is how can I factor 32? And how can I factor out a perfect square from 32? So we might need to take a second and remember that our perfect squares are, well, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, then we have 16 and 25 and 36 and 49, 64 and 81, and so on. This continues. These are perfect squares. So I want to think about what is the biggest perfect square that can go into 32, that 32 is divisible by. So 32 is kind of like right here on this number line, right? It's between 36 and 25. So 32 cannot be divided by 25, but 32 can be divided by 16. So I'm going to break this down to say I is the square root. This equals 32 can be divided by 16, and that's going to give me 2. So 16 times 2 gives me 32. So I can rewrite this as I times the square root of 16 times the square root of 2. And the square root of 16 is 4, so this becomes 4i times the square root of 2. Square root of 2 is a prime number. If I took the square root of 2, it would be some decimal, and I don't want to write decimals. I want to leave it in this nice pretty form, but 2 doesn't simplify anymore. It's a prime number. Okay, so there we go, we're done. So then I have number 2, square root of 28. I'm going to break this down. Again, let's see, 28 is over here on that same spot. 25 doesn't go into 28. 16 does not go into 28, right? No, we just did 16 times 2. Okay, sorry. 9 does not go into 28, but 4 does go into 28, and it goes into 28 7 times. So I can rewrite this as 4 times 7, which would be the square root of 4 times the square root of 7. Square root of 4 is 2, and the square root of 7 is not going to simplify nicely. It's going to be a decimal. 7 is prime. It doesn't simplify anymore, so that's it. We don't have an I here because 28 is not negative, it's positive. All right, next one is negative 50. Well, I'm going to take out that negative 1 first. Then I'm going to do 25 times 2. 25 is the biggest perfect square that goes into 50. So the square root of negative 1 becomes I. The square root of 25 becomes 5. And that's going to leave me with the square root of 2. Then we have number 4, negative 45. I immediately think of the negative 1 first, and then I'm thinking 9 times 5. 9 is a perfect square, and 5 is prime, so we won't be able to factor that any further. So the square root of negative 1 becomes I. The square root of 9 becomes 3. And all I'm left with is the 5 underneath my square root. Then we have number 5, square root of negative 98. Again, I can come up here. 98 is going to be right here between 81 and 100. Well, 81 doesn't go into 98. 64 doesn't go into 98, but 49 does. So I'm going to separate this. I have negative 1 times 49 times 2. And negative 1 becomes I. The square root of 49 becomes 7. And I'm just left with a 2 underneath my radical. So there we go. We simplified some radicals. There's an assignment that has 25 problems posted on it. If you have questions about that, please message me. Please email me. Okay? Do not suffer through. Reach out to me if you are struggling. I will talk to you later.